Okay, guys, I'm really happy. Good morning. It's like we have a fuller house today. Okay, for interest of those that are joining us today, my name is Engineer Chidi. I'm a software engineer, I'm also a developer. I'm the one handling this class. Sorry today I couldn't come on time. They blocked the road where I'm coming. So I have to run a lot of fun around to the point I have to leave my car there and start trekking because there's no other way. So that's why my colleague now want to go and sit on the car and retrieve it. That's why I'm coming late. I believe that next week we are going to be here on time. So sorry for that, not starting on time. Okay, so last week we started this course and we talked about software engineering, and we say that software engineering is a way we use engineering process to develop software. We described that there's a difference between a web developer, or rather a software developer, a programmer, and a software engineer. The difference is that in software engineering, we follow processes. In software engineering, we follow principles before we can develop the software, which the other two, developer and programmer, may not follow those processes. They may not even know about it. So not like they know it, but they don't want to follow it. They may not even know about it. So those processes is what makes the software engineering unique. That's what makes it a special field. We also say that software engineering is very big because some of those processes are so big that one can specialize in one of them. So when you are a software engineer, you have options of where you want to specialize. Only you can actually do all. But in some organizations, in some companies, especially abroad, they may not want only you to handle them because it can be overwhelming. They want you to specialize. So for those that we are here last week, can you mention any of those processes that will say software engineering follows? Is there anyone here that was here last week? There are processes that software engineering follows. Say what? Requirement analysis. You have to find out what the user wants before you start touching your keyboard. What's the next? If you're here last week, just wave your hand. Let me see people that are here last week. You're here last week. Ah, so go ahead and tell us now. Mention one.
Code design.
What is that? System design, not code design. So you design the system. After you have done the analysis, you design the system. What's next? Yes, you now code the design, or what we call implementation. You implement what was designed, and this implementation is where those developers and programmers come in. You can actually hire them to do the needful in that level of implementation. After that, what next? You test what they have done to see whether it match the requirement you have collected and the design that you have made. After that, you deploy the system. So these are the processes that are followed, and that is what makes software engineering. So today we are going to look at software development lifecycle. In biology, for those of us that did science, that did biology, there is I remember the life cycle of a butterfly. Who else remembers that? So if you think about it, there's a name they call that thing. That cycling, they call it metamorphosis, right? So software also have a life cycle. Software have a life cycle. There is where it should start, continue until when it ends, it continues again. That's why when you deploy a software, that is not the end of it. You now come into maintenance. That maintenance is what joins the beginning and the end. When you say something is a circle is a point that starts and ends where it started. So it keeps going around, keeps going around. That's how software development is. It doesn't end. It keeps going around. That's why if you are engaged in software development, you are there, you stay there. And we call it maintenance. So we want to study today what software development lifecycle is, and then what is involved in each of them. Today also, we are going to draw the software development lifecycle. And when you are preparing a document for software, it is required that you draw this lifecycle on that document, because that's what will help you or someone else to continue to develop that software, because it's a circle. So looking at the definition we have on board, sorry, I have a PowerPoint, but maybe because of the pressure, I couldn't find it here, but it's here. It's on my system. But the PowerPoint is derived from the Word. So since I was able to see the noise word, I don't want to further delay you searching for it. So we said that the software development lifecycle is a critical framework for developing reliable and scalable software. Understanding its phases and models is essential for software engineers and developers to ensure that projects are completed on time, within budget, and according to the required standards. These are the reasons why we make the life cycle drawings. We want the software that we are developing to be done on time and within the budget of the owner, and then meet the international standard. By following best practices and choosing the appropriate software development lifecycle model, teams can deliver high-quality software solutions that meet user expectations and business needs. So today's lesson will cover these key stages of software development lifecycle, their importance and best practices. So the first thing here asks it like a question. You say, what is software development lifecycle? So we say software development lifecycle is a systematic process used by software engineers and developers to design, develop, and maintain software systems. It defines the structured approach for software development, ensuring quality, efficiency, and consistency. So this software development cycle includes phases. When we say something has phases, that means you have to do the first one before you do the second one, before you do the third one, and so on. So these phases will guide the team. When we say team, because I've already told you that because of the largeness of software development, software engineering, only one person cannot do all that is required. So all the people involved, including you, the engineer, the developer, the programmer, the graphic designer, all the people that are involved, they are what make up this team that we are talking about. So if you adopt software development life cycle model, it will carry all the team along and make sure that all your efforts are concentrated towards achieving a software that is robust, that is efficient, and that meets the need of the owner. So this phase is guide the development team from the initial plan phase to the final release and maintenance of the software. The main objective is to produce high quality software that meets or exceeds customer expectations within a specified timeline and budget. So let's look at those phases now. Every software development lifecycle must follow these phases. The first phase is the planning or requirement gathering. You can see that what we learned last week will repeat itself here, but in a more organized form. We will now see how they are organized, depending on the model you want to adopt. but it's the same thing. But the systematic approach to it, which is this software development life cycle, now, is a systematic approach to software development, is now what will differ and make you say, okay, I'm using this type of model, I'm using the other type of model. The first phase in software development life cycle is the planning or the requirement gathering. The objective is to define the problem and gather requirements of the needs of the owner. So for the interest of those that are not here, but I can see that our number is bigger than how it was last week. When we talk about requirement gathering, someone come to you and say, I want to develop a software that if I just come into my room, the AC will on. That's what the person say he wants. As a software engineer, you're not just going to go to your keyboard and start typing code that will make if somebody walk in here the right now. You have to take your pen and paper and go back to that person and say, okay, you say if you walk inside your room, the AC will on. You say yes, it's okay. What if the windows are open? Would you like the windows to close first before the AC will on, or you just want the AC on? You say, how can you on AC with windows open? You have to close the windows now. You note it down. That's okay. What about light? Do you want light to on also, or you want it whether it's dark or it's light, just AC? He said, if it's in the night, you on light now. Note it down. He can also tell you, no, I don't want light on. If I leave my light on, leave it on. If I leave my light off, leave it off. I just want AC to be on when I come in. You also note it down. You ask him, would you like the door to close behind you automatically, or you want to leave the door open, or you want the door not to come into what you are doing, whether you close it or not? He said, I close the door now. Let me enjoy big manship. Just close the door for me. You note it down. That is what is requirement gathering. You see, when he told you to on the AC, that's just what he wants. But he didn't consider that there may be other factors. You can even ask him if the atmosphere is very cold, maybe during rainy, when it's raining and everywhere is cold, do you still want the AC on? You can say no. If the atmosphere is cold, I don't want AC on. I only want it when it's hot. You note it. What if there is no light and you're using your small gen? Do you still want the AC on? You say no. When I'm using small gen, I don't want it. But this is he didn't tell you this thing on time. What he wants is just let AC be on. So it is during the requirement gathering that you find out other non-functional requirements. That's what we call it. Other things that he did not mention but are important, because his aim is just on this AC, but he didn't consider other factors. It is through the requirement gathering process that you now find out other things that are required. So that is what this place is. It's not just something to say this is what I want and go and code. That's what programmers do. They just go and code. But as an engineer, you gather more information so that when the software is developed, the owner will be satisfied. What are some of the activities you do when gathering requirements? One of them is identify the software purpose, the goal, and the functionality. Then another activity you will do is to meet with stakeholders, just like what I was explaining. The clients, the users, the business analysts. Just like what I said, assuming the man said, if you are using small gen, I don't want the light to be on. As a big man, he is not the one that will be owning his gen. So another stakeholder you will go and meet is the person that owns the small gen or the big gen. The person has become part of the stakeholder of the software. So you have to go and meet him and say, when you own this small gen, how will your organ? He said, there is one small bulb somewhere. When I on it, this NEPA light will not, this bulb will not on. Is this one that will on? You note it down because it's a requirement. So when we say stakeholders, that what we mean. Everybody that is involved directly or indirectly in that software is a stakeholder. Do you understand that? Meet with them and gather functional and non-functional requirements. Who remembers what we call non-functional requirements? Okay, this is not What? Those things that are important, but the owner did not mention them to you because that's not what he's thinking. Look at where the owner functions. The owner functions here. That's all. The owner functions at the purpose of the software or what they want to achieve. That's just that's just where they end their own contribution. They'll be the ones to tell you, I want this thing on. That's what they want. They will go. So, and that is what we call functional requirements because that is the aim of the software. The non-functional requirements are those other requirements that he didn't mention to you, but they are important for his satisfaction. They are important for this software to function. You can even ask him, this software, do you want to have it on your phone or do you want it to be on your laptop? He said, I don't have a laptop, man. Let it be on my phone. You see, originally he didn't tell you. Now, assuming you think the man as a big man, he should have a laptop, and you go and develop a laptop-based software, and at the end, he tell you, I just want it to be on my phone. That means you have to go back again and start doing a mobile app because you did not gather non-functional requirements. Do we get this? So it's very important. So you meet with the stakeholders to gather some of those non-functional requirements. Then you create a software requirement specification document. One thing I want us to, we mentioned in the last class, but let me also remind you that what differentiates what a software engineer, the software he did, and the one that other people do is the documents that they produce. At every stage of software development lifecycle, a document is produced. Did we mention that last week? Yes. Every step of the way, you produce a document, and that is very important. In my exam, even in my major test, I'm going to ask you to mention the document that is produced at each stage. As you are giving me the stages, you are giving me the name of the document that is produced. So, at this level of software, of information gathering, a document is produced, and the name of that document is Software Requirement Specification Document. Because at this point, you have gathered all the information you need, both the functional and the non-functional requirements. You've gathered all of them. You now document it, put it in a document and keep it. Okay, so the next stage is the system design. I want this thing to be larger. So now you've gathered the information you needed for the software development. The next thing you do is to start designing it. So the objective here is to define how the system will be structured and designed. The activities you will do here are going to create system architecture, including database design, user interface design, and the system interface. So this is where you now make a design of, okay, I want them to click here, touch here, double click, long press, if it is mobile app or screen touch. You design that one. That's the interface. Then you design the components. You select the technology that will be used. So since this man said he wants this thing on his phone, am I going to use Android, or is it going to be iOS, or is it going to be cross-platform? If it is any of these, which language is the best for it? Is it Python? Is it JavaScript? You make those decisions at this design level. And when you are done, you produce a document that is called System Design Document, what is called SDD. So this design software system design document now is what we will now present at the next stage. So this next stage is the implementation stage. That's where you now call in the programmer, or the developer, as the case may be, for them to come and do the work. Now, at this implementation stage, which is number 3, we've discussed number 1, which is information gathering, number 2, design, number 3 now is the implementation, which is the coding, if you want to call it that. So at this point, you develop the software by translating it into code. It didn't end here. You have to also call the graphic designer to design a graphic for the software we use. If you're not a database person, you're going to call a database person to come and do the database management system and do the relationships and all that at this level, so that the software will be complete. So at this time, you produce the source code. Then you go for testing. So the objective of testing is to ensure that the software works as expected and meets the specified requirements. All the requirements have been specified in the requirement document and in the design document. So you have to check whether they meet whatever they produce as a software meets those requirements. The activities you do is to conduct various test types. So why we say there are many test types, you will test component by component, and you will also test. Okay, for people online. So how will I do that? How am I going to do that? You can't cut down it. You know, okay. Okay, so you test each component. What do you mean by component? You check if the man coming, is the AC on? You check that one is working. Okay, you check if the man coming. You just open one window and check if the man coming. Did the window close? You test them one by one, one by one, one by one. All those requirements. That is what is called unit testing. After the unit testing, you now test the whole system at once to see whether some windows are open, some are closed, the gen is on, the AC is there, the man walks in. If the gen is the one that is on, will the AC still try to on with the small gen? Those are some of the things we test. So when you do all these various testings, anywhere you find error, you correct it. Error in programs are called bug, and the attempt to correct them is called what? It's called debug. So you carry out debugging at this stage. Then the next thing is deployment. Deployment means you deliver the software where it will be used. If it's going to be a mobile app, you load it in the phone. If it's going to be a website, you host it. If it's going to be window-based, you install it. That's what is called deployment. And after that, you go to maintenance. So maintenance is where you now fix the software as they are using it. If there are some errors you didn't see that time, you tell me what to do. This one. Okay, so how do you do that? Okay. Let me put this option. Sharing. Yeah. I don't know if it's moving. Can you ask them? Or am I the one that running it? It's not. It's check. Check the light. It's not. I was moving it, but for them. Are you sure? Okay, so I should go ahead. It's moving. Okay. Okay, so the next stage is maintenance, and at this maintenance level, you monitor how the software is performing. If the software is having any issue, you correct it, and that is what we call corrective maintenance. You can also update the software by adding what was not there in the original plan. If there is anything that is not there in the original plan and they now want you to put it, it's called update. So you update the software, you bring the software up to date. If there are new software tools that are better in performance than the one you use, you can include them. That is update. Or if the man buys solar, thank you very much. Maybe the man is no longer depending on NEPA again. He went and bought solar and he wants to include solar in powering that place. That is an update because it wasn't there in the original plan. You add it for him. So now let's look at the software development life cycle now itself. We just defined all the processes that are involved. Now this is how you put them into diagram when you are preparing your document. The first software development life cycle model that we have here is the one we call waterfall. So this is the waterfall model. If you're using waterfall model, you gather requirements, you do the analysis, you design. You can see how analysis and design are running round and round. So you design, you check, you analyze, you design until when the design is done, you move to implementation. When you implement, you test. If you test it and it's not in order, you go back and redo what you have done until the software is accepted. Then you now go to maintenance and the cycle continues. Let's look at another one. Oh, okay, look at what they say about the waterfall. It's a linear process. Linear means it's in a straight line. You must do this one before you do this one, before you do this one, before you do this one. So you must complete this one before you move to the next. We usually use this one in small projects. Like if you have your own, maybe someone meets you and says, develop an e-commerce software for me. So you do that. It's a small software. But when you are doing a software that is too big, you may consider using other methods. Then the important thing about it, when we say pros, is the advantage of it, or the good thing about it is that it is simple and it's easy to manage. But the problem with it, or what we call the cons or disadvantage, is that it's not flexible. It is difficult to go back to previous phase once completed. So that's the problem with it. But let's look at the one we call agile method. Before you look at the big picture, let's look at the small one. Then we now look at how it works. In the agile method, you start from plan, you go to design, you develop, you test, you deploy, you review what you have deployed. That review is important because you have to monitor. Remember, we have produced the documents like the analysis document, the design document. You have these two documents. So you look at them, you look at the performance of that software, how this software is performing. Is it what we have in the design document? Is it the requirement that the owner of the software said he wants? You are reviewing it. Now, when you review it and it is not exactly the way it is, you go back to design. You start again, you design, you develop, you test, you deploy, you review again. You keep running down this circle until the whole process is done. Then you launch. I will ask you to draw this agile, but let me just show you this other picture up. Now, For each unit, remember we talk about unit testing. For each unit of the software, you are going to do this agile. For example, you are going to do this design requirements for when the man enter the room. If the man enter, he said once he enter, he want the AC to on, he want the door to close, he want the windows to close if they are open. You do that first one. You check when the man enters, what happened? Did the door close? Did the windows close? Did the AC on? If they don't, you will continue doing working on the software until these ones happen. You bundle it and you keep it one side. It is working. You now go and check the gen or the NEPA, which one is on. So you check if the NEPA is on. Did anything happen? If it is gen, did anything happen? You continue to work on that one until it starts functioning. That if it is NEPA, it will on. If it is gen, it will not on. You do that one, you keep it. You start up another testing. All the units that are required for that software, you're going to design them. Each one, you design it and you keep. Each one, you design it and you keep. And each one you design undergoes this cycle. It is not until when you are done with all the software that you start doing your testing. This one, you do one small unit, you test it, you go and design it again, you test it until it is fully functional. You keep it, you now go and get another unit. So that is what happens in Agile method. It is used for bigger projects. This method of doing one phase, one unit, moving to another unit, moving to another unit is what we call iterative. You are iterating as you do one. After that, you iterate in another one. So that is what Agile method is known for. So we say that Agile model is an iterative and incremental approach where software is developed in small functional segments or what we call sprints. So someone can ask you, a software engineer, yes, what model are you using for this work? We say Agile. It's okay. How many sprints? That means how many small units have you developed for this software? Regular feedback from users is incorporated into the development process. So as you design one unit, you test it, you get feedback, you check until all the feedbacks goes positive. Now move to the next one. The advantage is that it is flexible, it is adaptive, and it gives you faster delivery. Why do we say it's faster delivery? Because if you do all the software at once, like someone that is using the rainfall method, and an error happens, it will take you long to find out where that error is. But this one that is small unit, small unit, small unit, any error that happens, you know the unit where you have to go to fix it. One problem with it is that it can be challenging to manage the scope because there are so many of them as you are designing the sprints. So draw this agile method. Let me see. How do I see the people online? How can I see them here? Okay, comments. Yeah. Okay. So people online, you can as well draw and let me see what you have drawn, or indicate that you have drawn because it's a class work. How will I know how to draw agile? Because if you are looking at this place and drawing it, I wish there is a board like chalk. I wanted to draw it so that you see how easy it is. The first thing you do is you already know the processes of software engineering. That is the design, the information gathering, design, uh, analysis, information gathering, analysis, design, implement, test, launch or deploy, and then maintenance. That's seven. So you now know that you are going to draw this are okay. Maintenance is not here because this is just one step. So you stop at launch or implement. So you count how many steps, and these steps are going around the circle inside it. So that makes it very easy for you to remember. But if you are just drawing it like you are looking at a strange something and drawing, you will need to look at a drawing next time you want to draw it. But it's something you're supposed to draw from your head. All the software development life cycles, you're supposed to draw them from your head. Anytime you need it, you just rainfall, you put your arrow, you draw a square. All those software development life cycles, you're supposed to, if you just know the design process, that's all what it is. Put them in a box. For rainfall, put them in a box. For agile, put them in a circular form. That's all. If you're done, just wait. Let me see. Let me put it. Okay, that's good. Okay, yes. This I will understand. Your assistant is looking as if he's going to plan. He's actually going to design. Let's take note of that arrowhead. Because that shows the direction of the arrow. Remember, you are not artists. You are software engineers. So you're not actually drawing a painted, you're not supposed to draw a perfect drawing that best on the wall. What is important is the arrowhead and the text inside it. Once the arrow and the text make sense, then so you do the test. Okay, why this may not be agile is because it's not circular. Do you understand? You've got the names, but because it didn't appear in the second form, that makes it not agile. Fatima, you asked the question when the physical class will start. We are in the physical class. Oh. The physical class has started last week. So if you want to attend physically, you better come down to Cosmopolitan University and join. I'm talking to Fatima Ibrahim. All right. So that is agile. Now let's look at something that is called Scrum. So this Scrum is based on agile. It's based on agile, but it's focused on delivering software in a short time boxed sprints. Well, the initiator say it will last 2 to 4 weeks, but by practice, we now know that it can last as long as the software is large or as small as the software is small. The 2 to 4 weeks is just a theory. If the software is too large, it can take more than that. But what is important about Scrum is that these software are delivered in time boxed sprints. Look at what I've already shown you what sprints are. This is agile, and one agile like this is sprint. Like this one now, how many sprints are here? Good, that's what sprints are. So each of the sprints, you, the software engineer, will look at it and say, this sprint will last 1 week. This other sprint will last 3 weeks. This sprint will last 4 weeks. So by the time you sum them, that this one is 1 week, this one is 3 weeks, this one is 2 weeks, that will give you about 6 weeks. And you now know that this software will take us 1 month, 2 weeks to develop. That is what is Scrum. So in Scrum is like management. So like I was saying about having different fields in software engineering, you can decide to be a Scrum manager. As that's your job. The only is to make sure that all the teams working on this software deliver at that 1 week. So every day you look at them, you look at what they are doing, you have already given them tasks based on time. This software is supposed to last for 1 week, and it have 7 tasks. That means each day they're supposed to complete one task. Each day they're supposed to complete one task. If you come there by 4 and they're not even up to half of one of the tasks, you will know that they can't complete that task that day. In that case, you will sit down there with them. They are not going to go home. They're not going to sleep until they complete that day. Because if they can't complete that day, they will move it over to the next day. And before you know it, they can't complete it in that 1 week. And they will hold the Scrum Master responsible. So that's what Scrum is. Scrum works with Agile. It makes sure that each sprint have a specified time. Each sprint have a specified time, and that the time is maintained until the software is delivered. So the advantage is that it focuses on collaboration and constant feedback. So you have to always go check, are they where they are now? Will they meet up? Are they having any difficulty? Is there any issue? You get feedback from them, you go and you rethink, you come back again, you ginger the team, you make sure that every member of the team is working. That's what is collaboration. Those that are doing graphic, have they designed the logo? Are they the ones delaying? Have they designed the logo? The person doing database, has he produced the API for the other people to connect? You'll be checking all these things until you make sure that they deliver as at the time they should. There is another model called V model. So this V model is an extension of the waterfall. Remember that waterfall is linear, while agile is circular. So this V extension is also linear. It gathers requirements, does system analysis, software design, module design, testing, after coding, testing, integration, system acceptance. So this one is based on verification. That's why they call it V. It is not like Agile that tests unit by unit, but the testing power, advantage of the testing power of Agile, they want to implement it in rainfall method. That's why they now produce this vMeter. So there's a lot of testings. But the problem with them is that they test it when the whole software is developed. So they have to do the unit testing, which is checking each component one by one. They don't have to do the one they call integration testing. By the time they have integrated all the units, that's the whole system, they test it, then they now check acceptance. When this software is delivered to the owner and let them use it, did they accept it? Because you can design a software, because you are the one that developed it, you know that I should click here when I want to do this. I should click here when I want to do this. But the person you give it to, who has not used the software before, may be finding it difficult to remember how to use it. Just for example, because I am used to agile method, I know that it have to go in circle. So even when I don't remember all the things I should write inside those small boxes, I know I'm going to draw 7 of those small boxes, and I know I want to make them go round. But one of us here did his own in a rectangular form. Why did he do that? Because he's not used to agile. So to him, what is important is just to have those names, like analyze, design. That's just what he's interested in. He don't know that that circle is important, and that is what differentiates agile from other methods. So that is what happens with users. You can develop their software and give them to use. It's working. You, the designer, knows that you should click here, click here, click here. But when you give them to use, they don't know that they should click here and click here and click here. They'll be clicking wrong places and thinking that it's not working. That is what is called acceptance testing. You have to test, did they accept this software? Acceptance means, is it easy for them to use? It's not just functionality. Usability also. User-friendly, that is where the word comes from. You have to test user-friendliness of that software. So that is what differentiates this V model with the waterfall method. Waterfall just does one testing, but this one tests a whole lot of things. And that's why they call it validation phase. Then the spiral model. So this spiral model, as you can see, all of them is the same steps that we mentioned: design, analyze, information gathering, analysis, design, implement, test, deploy, maintain. All of these models. But what is different is the way you draw them. The spiral method is drawn like a spiral. You know how spiral goes? That's how to draw this one. So what makes this one different is that it adds risk analysis. It checks about risk. That's what makes it different from other models. So we said that the spiral method is a risk-driven model that combines elements of both interactive development and waterfall. Each phase involves planning, risk analysis, prototyping, and testing. So that risk analysis is the difference. So when you see this word prototyping, it means design. So when you say produce a prototype, what they are saying is produce a design. So the advantage of it is that it focuses on risk management. Risk management includes something like, if this man's phone lost, remember the man we used as an example that said they want AC, and they said they want the program on his phone. If the man's phone got lost, what happens to the software? What happens to the system of him working in? You have to consider that risk. What if the phone caught virus? These are some of the things you consider as risk analysis. What if one of the windows, the pen just fell off? Remember that the idea is once you're working, all windows should close. So if one of the pen of the window is missing, how will the window close? Are you following? And remember that if the window didn't close, the AC will not on. But his intention is once I come in, let my AC on. That's the focus. Now the man walks in and the AC did not on and the door did not close. Maybe he didn't notice that one of the window panes are off. He'll be angry with you, like, so this guy collected money from me and you didn't do this. So in spiral method, they take into consideration risks, those unforeseen occurrences, situations that are beyond the control of the software. How will you manage it as at that time? So that's when you now increase interactivity. The system will now be able to talk to the man either by a pop-up message or an alert. Tada, this window could not close. That's why the software is not on. So the man don't need to be angry with you. He need to look at the message, and when he see the message from the app, he can now check. Say, oh, okay. Or again, what if there's low current? He's using NEPA, so there is no reason why this AC will not on. But that was the agreement. Once I'm on NEPA, let it on. If they have low current, is it your what will you do? Doesn't concern you anymore, is it not? But the man don't know that there's low current. He just saw light outside and he came in and the AC did not on. And maybe he's coming with his friend, he want to show off, and the thing did not work. So you can imagine how angry he will be with you. But if at that moment he just walk in, he receive a pop on his message, tell him, he check, say low voltage, the AC could not on with low voltage. He will now at least rest a little. Is it not? You use. You are the one to use the one that suits what you are doing. That's why it's important that you study them very well. If the software you are building have no much, is not much under risk, if the software you are building is that it is. Domain life cycle. Okay, so the importance of software development life cycle, one is quality assurance. Quality assurance, because it will allow you to use a structured approach to ensure that the software meets high quality standard. Take that spiral, for instance. If you are developing a high risk software and you did not consider the risk analysis of that software, there'll be problem. Imagine if you are designing a software that can be used to transfer money. Maybe you are doing OPay software, for example, and you didn't consider security, because the owner of OPay is not thinking security. What he's just thinking is, I want a software that people can use to transfer money from my bank to their account, or from the OPay to their friend, or anywhere, any business they want to transact. That's just what he's thinking. But you now, as the engineer, you have to go to those non-functional requirements, which involve the security of the system. And because there is high risk in such software, you have to use the spiral method so that you will take care of that risk part of it as it goes. Or you are developing Uber app. The owner of Uber app, what his mind will tell you is, a software that you use to book taxi. That's just what he's thinking. He's not thinking about the safety of the person that is booking it. He's not thinking about the safety of the person that the passenger and the driver. But you that are designing it, you cannot think of, okay, let me just add a small camera so that if they are trying to strangle someone in that, so long as the person book with Uber, I will see it. So those are some of the risks that you have to analyze when you are developing a software. In that case, you know you are going to use agile method so that you will meet high quality standard. Efficiency. A clear roadmap helps to minimize delay and budget overrun. When you learn a good one, you learn a bad one. Why budget is being mentioned here over and over again? Someone commissions you as a trained software engineer, and as you're building the software, something happens along the line. The person will pay again. If he refuses to pay, he forfeits the one he has paid before. But we don't want to be doing that, because if you do that, the person will not call you again. I hope you know. The person will also not recommend you to another customer. And as an engineer or any field whatsoever, referrals is what boosts your business. But if you did not serve the person well, they won't call you next time. But however, what we are saying here is that if there is any mistake on the software, the person will pay again, and the cost will be increasing. So if you don't follow this engineering process, there is likelihood of the man paying and paying and paying. If there are security issues, he will be paying to patch it. If there are fine loss, he will be paying, and at a time he will be tired of paying. And he may not hire you again, and that's not good. So to make sure that budget is not ballooned, you have to make sure you follow these processes. They save cost. That's what I want to say. Another important advantage of software development life cycle is stakeholder communication. Because of the continuous feedback, the feedback process, you talk to the owner, they review, you check whether what you have done is okay. They say no, do it like this. You go back, you do again, you check user friendliness. If it's not friendly, you go back, you do it. And at the time, once you are done, the software becomes perfect for them. So the software development life cycle is very important when you are building the software. What are some of the best practices? Number one is clear requirement gathering. This requirement gathering is one of the best practices when you are doing software engineering. When you are developing any software, you have to know exactly what the person wants, and even go beyond that. After you get what the person wants, you also have to go and get what the software wants, so that it will function very effectively. Another good thing is maintain documentation. Software development life cycle will help you to have a documentation. We mentioned the advantage of documentation last week. You can remember one of them. Why should we have a documentation? And why do we lay emphasis on that? Yes. But why is it important?
So that in your absence,
Another person can look at it. Even in your presence, can you remember everything you have done? No. You have to go back to that document and say, how did we even make this software to close that window? Let's say that one window fell off, and the man say, is there no way your software can ignore, if a window fell off, let it ignore it? The only place you can write a code that will do that is to go back to the code that is controlling Windows. Then how will you know where the code that is controlling Windows are when there's no document that will show you where it is? I don't know if you have seen software code before. Sometimes it's more than 100 pages. If you write a software that is 100 pages only, it's a small software. Some softwares run up to 2,000 pages, 3,000 pages. And if you don't have a document to know where to trace it, then there's a problem. So the document is not just helping another person, it's also helping you that designed it. But now check if you that designed it is having problem to find where it is without the document. Do you think another person can even know where it is? So that's one advantage of documentation. So it's very important. And if you don't follow software development life cycle, you cannot do good documents. Because each stage you prepare a document. Each stage you prepare a document. That's what makes the document robust. Another advantage is regular. So by the time you test the software, you find out that testing the software is like you writing a letter and then reading that letter again. That's what testing is like. If you write a full page letter and you come back to read that letter again, you see that there are some places you didn't put comma. You see that some places you do spelling error. You see that some places you omit one word. So testing will help you find out those things and debug them. Another advantage is version control. We will talk about version control as a topic for another day. No, we're not just going to talk about it, we're going to do it because it's part of what software engineers do. Have you heard of GitHub before? That's what is version control. So you write your code, this is version 1, you keep it. You write another one, this is version 2, you keep it. Without software development lifecycle, you cannot do version. So when we say version control, it's not necessarily version 1, version 2, version 3. If you look at sprints, this can serve as version 1, even though it is just a unit. Those units can be stored as versions. So you can now integrate them into one. And then iterate quickly. If you're using agile practices, you do one unit, you keep it, you do another unit, then you put them together. One advantage of using this component, we call it component-based method. That's when you do sprint by sprint. If a particular module is having problem, you can easily decouple it while the whole other software is working. It's like when you're using your system and you have a pop-up window that is telling you that, oh, this software you want to use is not supported by Windows. If you click cancel, it will go off so you can open another one and work. But imagine if that thing pop up and say this software is not supported by Windows and it refuses to go off. The whole system hangs. That is what happens when you did not componentize your software development. If you do all your programs one body, anywhere that have problem, others will stop working. But if it is done component by component, if a component have problem, it decouples itself. Others will be working. At least they can be using the other ones until you fix this one. That's why sometimes you see a bank program, you can transfer money, but alert is not working. But that alert is not working does not bring the whole system down because it's component by component. Yes, you can see withdraw and things like that. You do some parts are not working until they fix it all. So that is agile practice. Call it agile practice because of the sprint or component method of development. So that's what we have for today on software development lifecycle. And we have already said that software development lifecycle is one of the engineering process that we use in building a software. We use each of the software development lifecycle model you choose have to be dependent on the type of software you are building. We have the ones that have high risk. We have the ones that are so large that you don't need to do all at once. And we have the ones that are small, so you just use a smaller model to handle it, and so on. So that's what we have for today. If you have questions, if you have comments, you are free to say it.
Sir,
Yes?
you have to get the map on it.
Yes, that's what I'm reading now. Someone said it online here.
Yes, sir. The other question, how is the software of this one?
Yes, is Cosmopolitan here? Are you the one? Are you the one? The last week, they said they will post it. They will send it to you guys. I hope you guys have a WhatsApp group. So they will post it. Maybe after today's class, I will meet with them because it's important that you guys have this note so that you can have something you can be reading. So I will meet with them to make sure they release it. I was thinking they have released it last weekend, but since you requested it again now, that means it cannot be released. I will see that they release it, if not today, before our next meeting. Any other comments? So online, Farouk Idris, I've answered you. Sam, I've answered you. Who else? Okay, these are the people that asked about the handout, also the soft copy of the today's class. All of you will get it, if not today, but before the next class. You get both the first week and the second week class. Thank you. All right, we've come to the end of the class for today for the first group. Except you still have something to ask. Otherwise, the class is over. Thank you and have a nice day.
Thank you, sir.
Thank you, sir.
Yes. Check your. For those who don't have their ID card, please, you can go to the website and generate your ID card over here. Just put your email